So, black holes. You've probably heard they're these terrifying cosmic monsters that suck everything in. But here's the thing, that's not really true. They're way weirder than that. Let's start with how they're born. When a massive star, like really massive, runs out of fuel, it collapses under its own gravity. And I mean collapses. We're talking about a star maybe 20 times the size of our sun squishing down to something smaller than a city. That collapse triggers a supernova, a massive explosion that can outshine an entire galaxy. And what's left behind? A black hole. Now, what actually is a black hole? It's not a hole in space, like a puncture in fabric. It's an object, a ridiculously dense object. So dense that its gravity is insanely strong. But here's where it gets weird. There's this boundary called the event horizon. Think of it as the point of no return. If you cross it, you can't come back. Not because you're being sucked in, but because space itself is falling faster than the speed of light. Yeah, you heard that right. Space is falling. It's like trying to swim up a waterfall that's flowing faster than you can possibly swim. You can't beat it. And time? Time gets completely messed up. Near a black hole, time slows down. If you were watching someone fall in from a safe distance, they'd appear to freeze at the event horizon, getting redder and dimmer until they fade from view. But from their perspective, they just keep falling. They'd be shredded by tidal forces first, spaghettification, it's literally called that, long before reaching the center. At the very center is the singularity. That's where all the mass is crushed into a single point of infinite density. Our physics breaks down there. We don't know what actually happens. Einstein's general relativity says one thing, quantum mechanics says another, and they don't agree. It's like having two maps that both work perfectly for different parts of your journey, but completely contradict each other where they meet. Now, you might have heard Stephen Hawking discovered that black holes aren't completely black. They actually emit radiation, Hawking radiation. Tiny particles pop into existence near the event horizon, and sometimes one falls in while the other escapes. The black hole loses a tiny bit of mass. Over ridiculously long timescales, like longer than the age of the universe for most black holes, they eventually evaporate. Poof, gone. Oh, and size varies a lot. Stellar black holes are a few times our sun's mass. Then there are supermassive black holes at the center of galaxies, millions or billions of times heavier than the sun. Our Milky Way has Sagittarius A star, about 4 million solar masses. And recently, we've found evidence of intermediate black holes somewhere in between. We didn't even see a black hole directly until 2019. But we knew they existed because of their effects. Stars orbiting invisible companions at insane speeds.
Gravitational waves, ripples in space-time, when two black holes collide. That's such a massive event, it literally warps reality and sends shivers across the cosmos that we can detect billions of light years away. So yeah, black holes aren't cosmic vacuum cleaners. They're not evil. They're just consequences. Extreme consequences of gravity doing its thing when matter gets squeezed beyond what we thought possible. They challenge everything we know about physics, and honestly, they remind us how much we still don't understand about the universe. And that's pretty cool.